Hey guys, so in this video we are going to discuss how to obtain roots of nonlinear equations using bracketing methods. Okay, so let us start our discussion by taking a look at the area of a segment of a circle. So if the shaded area here is equal to AS and then the radius of our circle is R, then the area of the segment is equal to 1/2 r squared times theta minus sine of theta. Okay, so yung theta dito is obviously naka-radians dapat. Now, let us say that we are given the values of the area of the segment AS and then the radius of the circle R. So, hahanapin natin yung value ng included angle theta. So, from this given equation, kahit anong gawin natin, we simply cannot manipulate this equation to explicitly solve for theta. In other words, we cannot isolate the angle on the left side or on one side of our equation here. So instead, yung gagawin natin is we will subtract both sides of our equation here by the area of the segment AS. So now we will have a new function f of theta equal to 1/2 r squared times theta minus sine theta minus AS. We can see na yung sagot or yung answer to the problem is the value of theta that will make this function equal to 0. And we call that the solution or the root of this function. So this function here is an example of what we call a roots problem. These types of problems or equations might have no solution or can have one or several roots. For example, dito sa first graph natin, we can see that the graph of our function, yung f of x natin, it does not touch or intersect the x-axis. Ibig sabihin, there is no value for x that will make the function equal to 0. And here in our second graph, you can see that our function is tangent to the x-axis at one point. Okay? So at this point, yung value ng function natin is equal to 0. So in this case, there is a single value of x that will make the function equal to 0. So in this case, meron tayong iisang solution. Similarly, here in our next example or in our next graph, we can see that the function crosses the x-axis at this point. Ibig sabihin, at this point, yung value ng function natin is equal to 0. The value of x here will be the solution or the root of that function. So again, in this case, it only crosses or intersects the x-axis on a single point. Therefore, it only has one solution. Now, there are also cases where the function has multiple solutions. Ibig sabihin, yung graph niya crosses the x-axis at multiple or at several points. So, each of these points of intersection, so yung value ng x dito, is a root or a solution to our function. Again, in this case, we have multiple points of intersection. Ibig sabihin, we also have multiple solutions to our function. So, I know na napakarami niyo nang na-encounter na ganitong mga klase mga problem on your previous subjects. So, usually, yung ginagamit natin to solve or yung ginagawa natin in order to solve these types of problems is yung tinatawag natin na analytical solution. So, an analytical solution is obtained by deriving an expression that has an exact numerical value. So, yung ginagawa dito is we isolate the unknown variable on one side of our equation and then we simply solve for the value of that unknown variable. Then again, as we have shown kanina, there are also cases that we simply cannot do this. Okay, so, hindi natin pwedeng i-isolate yung unknown variable sa iisang side. So, ano yung gagawin natin? So, shift solve, no? So, paano na lang kung walang shift solve yung calculator nyo? So, dito napapasok yung numerical solution. So a numerical solution is obtained in a process where an approximate solution is first obtained, and then a numerical procedure, or what we call an algorithm, is performed in which a better or more accurate, although not necessarily exact solution is determined. So the methods used for solving equations numerically can be divided into two groups. So first, meron tayong tinatawag na bracketing methods. And then second, we have what we call open methods. Okay? So ito yung overview ng bracketing method na tinatawag. In bracketing methods, an interval is first identified. Within that interval, dapat nandun yung actual solution ng function natin. So the endpoints here, yung endpoints ng interval natin, are values of x. We call this the upper bound and then lower bound of our solution. And then, yung ginagawa sa bracketing method, we apply an algorithm that reduces the distance between the endpoints of our interval. So the repeated applications of these algorithms is what we call iterations. Okay? So for each iteration, yung interval natin is lumiliit siya ng lumiliit. And we can simply perform these iterations, so more iterations, until we achieve the desired accuracy of the solution. So yung kagandahan lang sa bracketing methods is that it always converges to the solution. Lumalapit talaga siya ng lumalapit dun sa actual solution because the interval encloses or brackets the actual solution. So nandun siya in between our boundaries or our interval. As we perform more iterations, we will obtain a solution that is very, very close to the actual solution. So in open methods naman, an initial estimate for the solution is first assumed. So iisang solution or iisang value lang yung ina-assume natin initially in open methods. So the value of this initial guess should be close to the actual solution. And then by using an algorithm, we will obtain better or more accurate values for our solution. So as we perform more iterations, yung estimate natin, it gets closer and closer to the actual solution. Again, yung main difference ng bracketing and open methods is yung initial values na ina-assume natin. So for bracketing methods, dalawa. And then for open methods naman, there's only one. So open methods are usually more efficient, but sometimes might not yield the solution. So minsan yung algorithm, it yields a value that is receding from the actual solution. So instead of giving a value that is closer to the actual solution, yung nangyayari is when we perform or when we apply the algorithm, yung value na nakukuha natin is lumalayo ng lumalayo doon sa actual solution natin. So yun yung downside ng open methods. But when it converges or kapag lumalapit naman siya doon sa actual solution, it does so in a much more efficient and a much faster way than bracketing methods. Again, sa bracketing method, although minsan slow siya, pero eventually magko-converge siya doon sa solution. And then sa open method naman, merong chance na mag-diverge siya doon sa actual solution, papalayo. Pero pag nag-converge siya, mas mabilis niya namang nakukuha yung actual solution. So again, in this video, we are going to discuss bracketing methods. The first method under this is what we call the bisection method. So again, basta bracketing methods, yung first na gagawin natin is we choose an interval by finding points, okay, so dalawang points, A and B, such that a solution exists between them. So yung actual solution or yung true solution natin dapat nandito inside our interval. So paano natin malalaman kung nandito or merong solution in between our assumed interval? If we take a look at the graph of our function here, makikita natin that, again, it intersects the x-axis. And this point of intersection is the root or the true solution of our function. Kung mapapansin nyo, again, because it intersects the x-axis here, one side of the function has a positive value and then yung sa kabilang side naman ng function natin, negative yung value niya. So what we can do in order to check if a solution is between our assumed interval is we can simply check the sign of the value of our function on these assumed intervals or assumed boundary. So kukunin lang natin yung value ng function natin at point A and then at point B. And then if these two values have opposite signs, ibig sabihin, somewhere in between these intervals, it crosses or it intersects the x-axis. Therefore, somewhere between our interval lies the true solution of the function. Now, if we have determined that a solution lies between our interval, the next thing that we are going to do is we are going to calculate the first estimate of the numerical solution. So, tatawagin natin siyang x sub ns1. So, ns, that stands for numerical solution. So, in bisection method, this estimate is obtained by simply taking the midpoint of our boundary or our interval. So, that will be equal to a plus b divided by 2. Kaya nga tinawag siyang bisection method, no? Bisection. So, hahatiin natin siya at the midpoint. After obtaining our first estimate, yung next na gagawin natin is we will determine kung nasa ang interval yung true solution natin. So, is it between A and X and S1 or is it between X and S1 and B? In order to do this, we will simply, again, take a look at the sign of the function at these values. So, we will simply compare the values of f of a and f of x and s1. If opposite yung sign nila, the function crosses the x-axis between these two interval. Okay? Kasi yung isa, positive or negative, and then yung kabila naman is opposite yung sign niya. But if these two values have the same sign, ibig sabihin, it does not intersect the x-axis, so the true solution does not lie between these two intervals. Similarly, we will check the sign of the value of f of x and s1 and f of b. And then again, if opposite yung signs nila, the true solution lies between this interval. So let's say na yung true solution natin is in between x and s1 and b. For our next iteration, itong interval na to naman yung gagamitin natin. Ibig sabihin, yung x and s1 natin, ito na yung magiging lower bound or new value ng a natin. And then, yung b naman is same pa rin. Siya pa rin yung upper bound natin. Again, for the next iteration, ito na yung gagamitin natin na interval. And then, we will simply repeat our process. So, we will calculate the next estimate for our numerical solution. So, using the same function, a plus b over 2, we will obtain the new estimate. And then, after that, i-check na naman natin kung saang interval yung true solution. So, is it between our lower bound and our estimated solution, or is it between our estimated solution and our upper bound b? So, the interval where the true solution lies, yun naman yung gagamitin natin for the next iteration. And then we will simply repeat this process until a specified tolerance or accuracy is obtained. So let's take a look at this example here. Determine the first root of f of x equal to negative 30 plus 3x plus 18x squared minus 81x cubed using bisection method and with relative error of less than 2%. So again, usually yung ginagawa nyo dito is simply shift solve. Okay? Pero paano pag walang shift solve yung calculator mo? Okay. So again, importante din na alam nyo kung paano i-solve ito numerically. as the problem suggests, we will apply bisection method. So recall na first thing na ginagawa natin is we choose an interval by finding points A and B such that a solution exists between them. So let's say yung value ng A natin is negative 1 and then yung B naman natin is 0. Kayo nang bahala kung ano yung initial interval nyo. So just check if the true solution is in between these two intervals. To check, yung gagawin lang natin is we will simply take a look at the sign of our function at these points. Substitute lang natin yung value ng A and B into our function. And we can see that the value of our function at point A is 66, positive 66. And then at point B naman, yung value ng function natin is negative 30. Ibig sabihin, somewhere between points A and B, nag-intersect yung function natin doon sa x-axis. Ibig sabihin, between A and B lies a solution or a root to our problem or to our given function. The next thing that we are going to do is we are going to calculate the first estimate of our numerical solution. From our formula, madali lang tandaan, no? So that is simply A plus B over 2. This will give us the value of our first estimate that is equal to negative 0.5. And then, next na gagawin natin, diba, is we will check kung saang interval naman yung true solution natin. Is it between our lower bound and our estimated solution, or is it between our estimated solution and then our upper bound? So, in order to do that, i-check nyo na lang kaagad yung sign ng function natin at this point, okay, doon sa estimated solution natin. So, substituting this to our original function, we will have the value of f of x n s 1 that is equal to negative 16.875. Again, yung titingnan lang natin dito is yung sign. So, as you can see, the interval where a change of sign occurs is between A and our estimated numerical solution. Ibig sabihin, for our next iteration, we will utilize this interval. Okay, so for our second estimated solution, we will have A plus B over 2. A natin, that is same pa rin, negative 1, plus yung bagong value ng B natin or ng upper bound natin, which is yung estimated numerical solution natin on our previous iteration. For our next estimate, we have negative 0.75. And the next na gagawin natin is we will identify kung saang interval naman yung true solution natin. Again, is it between A and X and S2, or is it between X and S2 and B? So, in order to do that, again, check lang natin yung sign ng function natin at this point. So, the value of our function at x and s2 is equal to positive 12.046875. Again, yung number of significant figures dito, hindi naman importante kasi titingnan lang natin yung sign. So, as we can see here, there is a change of sign between f of x and s2 and then f of x and s1. So again, recall yung x and s1 natin on our previous iteration is yun na yung value ng upper bound natin dito sa second iteration. So ibig sabihin, the true solution lies between our estimate or yung midpoint natin and the upper bound or yung point B. We will simply repeat this process, so we will need to perform more iterations until we have satisfied the condition given in the problem. So yung sabi din sa problem, dapat daw yung relative error is less than 2%. So we calculate the estimated relative error using this formula. So we have the absolute value of x and s old minus x and s new divided by x and s new, and then we will simply multiply that by 100%. For our first two iterations, ito yung magiging value ng estimated numerical solutions natin. So for our old numerical solution, that will be equal to negative 0.5. So, yan yung nakuha natin doon sa first iteration. And then, yung nakuha naman natin for the second iteration, that is xn is new, that is equal to negative 0.75. Okay, so this is equal to 33.33%. This is greater than 2%. Ibig sabihin, we will need to apply the algorithm or we will need to iterate more. Okay, kasi hindi pa natin na-satisfy yung condition na binigay ng problem. So, I suggest that you try this for yourself, no? So, napakadali lang naman ng procedure na gagawin nyo. After 7 iterations, your relative error should be less than 2%. And then you will have the value for your estimated numerical solution, and that will be equal to negative 0.66407. Of course, you can perform more iterations, 8, 9, or 10 or more iterations if you want to have a more accurate solution. But in this case, because the problem only requires a relative error of less than 2%, ibig sabihin, itong sagot na to is tama na. Enough na siya. Additional notes sa bisection method. So first, it always converges to an answer. Again, basta bracketing method, as long as continuous yung function natin between our interval, we'll always converge to a true solution. And then for number 2, the bisection method may fail when the function f of x is tangent to the x-axis. As you can see in this graph, a true solution lies between our interval. But the values of our function on these intervals, kung mapapansin nyo, they are both positive or they have the same signs. Kung yung checking method na ginamit natin kanina, yung gagamitin natin dito, we will conclude that there is no solution between these two intervals kasi same lang sila ng sign. But in this case, kasi tangent siya, meron pa ring true solution between the interval. So using bisection method, we will not be able to identify kung meron talaga doong solution. Okay? Kasi initially, hindi naman natin alam kung tangent ba yung function natin sa x-axis. So yung ginagawa lang natin, again in bisection method, is we check for change of signs. And then lastly, bisection method converges to the true solution slowly. Okay, so you need to perform more iterations in order to obtain a more accurate solution. So next method that we are going to discuss under bracketing method is the false position method. So it is very similar to bisection method with the exception that it uses a different strategy to come up with its new root estimate. But the first thing that we are going to do is similar lang sa bisection method. So first, we will choose an interval by finding points A and B, again, such that a solution exists between them. This means that yung value ng f of A natin and f of B have different signs. In false position method, the next thing that we are going to do, unlike doon sa bisection method, so rather than bisecting the interval, we will locate our new root by joining the points f of A and f of B with a straight line. And then the intersection of this line with the x-axis represents the new root estimate x sub ns1. And then after that, we will simply determine whether the true solution is again between A and our estimated solution or between our estimated solution and B. In order to do that, again, yung gagawin lang natin is we will simply check the signs of our function at these points respectively. Kung saan yung merong change of sign, nandoon yung true solution natin, and then we will simply use that new interval for our next iteration. Similar lang siya doon sa bisection method. Yung pinagkaiba lang nila is the way that they come up with a new root estimate. So for the false position method, we have this formula. x ns1, so that is the value of our numerical solution, and that is equal to a times f of b minus b times f of a all over f of b minus f of a. Again, yung a natin dito is yung lower bound, and then yung b naman natin is yung upper bound ng interval natin. So let's go back to our previous example. But this time, we will use the false position, or sometimes it is also called regula falsi method. So using the same values for our initial interval, we have a equal to -1 and then b naman equal to 0. Again, checking the values of our function on these points, we can see that there is a change of sign. Therefore, the true solution is somewhere in between these 2 points. So for our next iteration, we will simply calculate the value of our numerical solution. We will use the false position method formula, and then we will simply substitute the values here, and then we will obtain the value of our first estimate, and that is equal to -0.3125. Again, next thing that we are going to do is determine on which interval does our true solution lie. So checking the signs of the value of our function between these points, makikita natin na nagbago yung sign ng function natin between our lower bound a and our estimated numerical solution. Yung f of a natin positive, and then yung f of x ns1 natin is negative. So our true solution lies between a and our numerical solution. So, using this new interval for our second iteration, so again, yung x ns1 natin dito, ito na yung magiging upper bound b natin. So, isa-substitute lang natin yung mga values doon sa formula natin. We now have the new value of our estimated numerical solution, which is equal to -0.51056. Again, let us check na lang yung sign ng function at this point. So we can see that the sign of our function at this point is negative. Ibig sabihin, yung true solution natin lies between a and this new estimated numerical solution. So for our next iteration, ito naman yung gagamitin natin na interval. So again, we need to perform more iterations until we satisfy the condition given by the problem, which is a relative error of less than 2%. So let us calculate our estimated relative error after 2 iterations. We can see that our estimated relative error after 2 iterations is equal to 38.79270%, which is way greater than 2% na required doon sa problem. So we need to perform more iterations. After 6 iterations, which is 1 less than the bisection method, our relative error is now less than 2%, and then we have the estimated value or our numerical solution, and that is equal to -0.66396. As you can see, similar lang yung bisection method and then yung false position method. The only difference is yung formula na ginagamit para makuha yung bagong estimate for our solution or for our root. But in other steps, similar lang silang dalawa. Okay, that's it for this video. Hopefully, meron kayong natutunang bago. So, see you on the next one. Peace!